Good day, Math Buddies! Sir Sherwin here, your math instructor. Welcome to another content where we are learning mathematics lesson in an exciting and interesting way. For today's lesson, we will be discussing all about quadratic inequality in two variables. But first, please don't forget to subscribe on my YouTube channel and hit the notification bell for more updated contents. Alright, dear math buddies, as what we stated a while ago, today we will be discussing all about quadratic inequalities in two variables. And to start, let us first define quadratic inequalities in two variables. It is an inequality of degree 2, written in the following forms. Y is greater than ax squared plus bx plus c. Y is less than ax squared plus bx plus c. Y is greater than or equal to ax squared plus bx plus c. And y is less than or equal to ax squared plus bx plus c, where a, b, and c are real numbers, and a is not equal to 0. So let us try to determine the different solutions of a quadratic inequality. Let us have our first example. So for our first example, let us try to determine the solutions of y less than x squared plus 3x plus 2. For us to determine the solutions of this quadratic inequality, first thing that we need to remember is to write our inequality into its corresponding quadratic equation. So we will simply change the inequality symbol into equal sign. So we will let y equal to 0, making this one a quadratic equation. So we have 0 equals x squared plus 3x plus 2. By symmetric property, we can write our quadratic equation as x squared plus 3x plus 2 equals 0. And we've learned that there are 4 methods used in solving for the roots of a quadratic equation. It can be by extracting square roots, by factoring, by completing the square, and by using a quadratic formula. But in this case, allow me to use factoring. So, the possible factors of our given trinomial would be quantity x plus 1 times quantity x plus 2 equals 0. Then apply zero product property. We will have x plus 1 equals 0 and x plus 2 equals 0. So we will have the first solution. We have negative 1. And the second solution is equal to negative 2. So the possible roots of our x squared plus 3x plus 2 equals 0 would be negative 1 and negative 2. After we get the solutions or roots of our quadratic equation, the next thing that we will do is to create a table containing the solutions itself, negative 1 and negative 2. So we will create a table. The first column is for our x and y. So we have negative 2, negative 1, 0, 1. So allow me to use negative 3 before negative 2. So negative 1 and negative 2 are the values of our x when y is 0. Because earlier, we let y equal to 0. Then we will complete the table as we get the value of our y when x is 0, when x is 1, and when x is negative 3. So first, we will determine the value of our y when x is negative 3. So using our quadratic function, y is equal to x squared plus 3x plus 2, we will determine now the value of our y. So here, we will determine our y when x is equal to negative 3. That is, substitute all x in our quadratic function to solve for y. So we have negative 3 squared plus 3 times negative 3 plus 2. So we have y is equal to 9 minus 9 plus 2. Finding these terms, we will have y is equal to 9 minus 9, that would be 0, plus 2, we have 2. So therefore, the value of our y is 2 when x is negative 3. Then, we will also determine the value of our y when x is 0. So here, if x is equal to 0, we will have y is equal to 0 squared plus 3 times 0 plus 2. To simplify, we will have y is equal to 0 squared, that will be 0, 3 times 0, that will be 0, and copy the constant 2. Then we will have y is equal to 2. This means y is 2 when x is 0. And to complete our table, let us determine the value of our y when x is equal to 1. So if x is equal to 1, so y is equal to, substitute all x by 1, so you have 1 squared plus 3 times 1 plus 2. So to simplify, we will have y is equal to 1 plus 3 plus 2. So we have y is equal to the sum of 1, 3, and 2. It is 6. So the value of our y is 6 when x is equal to 1. So after we complete the table of values for our x and y, the next thing that we will do is to graph our quadratic inequality. So here, utilizing the table of x and y, let's try to graph. First, let's draw a Cartesian coordinate plane, and if we will see the value of our y is positive, so we will have to adjust our Cartesian coordinate plane. So we will plot our ordered pairs to create the graph of our quadratic inequality. And of course, let's try to connect the following points as we create the graph of our quadratic inequality. But in connecting the graph of our quadratic inequality, let's also remember the symbol of inequality that we are using. In this example, we are using the less than symbol. If we are using the less than or greater than symbol, just like in our quadratic inequality in one variable, we will utilize not a hollow circle, but instead we will be utilizing the broken line. So again, if our symbol is less than or greater than, we will use broken line. And if our inequality symbol is greater than, equal to, and less than or equal to, we will apply the solid line. But again, we will try to connect the points using the broken line. So, connecting points of our quadratic inequality is through the use of our broken line. So, we will try to have a turning point here. Alright. And let's try to extend this one, and we are creating a graph. By the way, the graph of our quadratic inequality is known as parabola. So, graph of our quadratic inequality, in the same time, the graph of our quadratic function is known as a parabola. And the turning point of our parabola is known as the vertex. Then, after we draw our graph, the next thing that we will do is to test which part of our graph will be tested. So, we will test a point that can be found inside our parabola and a point that is outside our parabola. So if we are to look at our graph, there are different points present. There are different points present inside our parabola, and there are also points present outside our parabola. So we will test 2 points. One point is a point that is present inside our parabola, and another point that is present outside our parabola. So we will try to test point inside our parabola. Okay. Any point that is inside our parabola can be utilized in testing. So I can have this point negative 1, 1 as my testing point. I can have this point as my testing point, which has a coordinate of 0, 4. And I would suggest that we will utilize points that is present along our x and y axis to have an easier identification of our ordered pairs. So here, allow me to use this point, and the ordered pair is 0, positive 4. So we will utilize the point 0, 4, where our x is 0 and our y is 4. So using our quadratic inequality, which is y less than x squared plus 3x plus 2, we will substitute our x by 0 and our y, which is 4. So utilizing our quadratic inequality, y less than x squared plus 3x plus 2. So our y is 4 and our x is 0. So substitute our x by 0. Then simplify. 4 is less than 0 plus 0 plus 2. 4 is less than 2. Is 4 less than 2? Of course, the idea is considered to be false because 4 is greater than 2. So we will try to label this as false. So this time, let's also test point outside our parabola. So allow me to utilize this space in testing for point outside the parabola. And I would suggest that if point of origin is available, you can use this one as our testing point. So here, we will utilize 0, 0 as our testing point because it is found outside our parabola. So we will use the ordered pair 0, 0, where x is 0 and y is 0. Again, utilizing our quadratic inequality, y is less than x squared plus 3x plus 2. So we have y less than x squared plus 3x plus 2. Substitute all x by 0 and our y by 0. So we have 0 less than 0 squared plus 3 times 0 plus 2, which leads us to the idea 0 is less than 2. So of course, 0 is less than 2, and this concept states that this is considered to be true. Because we test that point outside the parabola is true, this means we will shade points outside our parabola. And what does it signifies? This means that all points outside our parabola are considered solutions of our quadratic inequality. So all points that can be found outside our parabola are solutions of our quadratic inequality. And for our conclusion, we can state that the solutions of y less than x squared plus 3x plus 2 are all points outside our parabola. Let's have our second example. Let's determine the solutions of y greater than or equal to x squared plus 9x plus 14. So again, our first step is that we will write our inequality symbol into quadratic function by changing the inequality sign into equal sign. So that is y equals x squared plus 9x plus 14. Then, we will let y equal to 0, making our quadratic function a quadratic equation. This leads us to 0 is equal to x squared plus 9x plus 14. And by symmetric property, we can write our quadratic equation as x squared plus 9x plus 14 equals 0. Next is, we will determine the solutions or roots of our quadratic equation. And in this case, allow me to use factoring. But of course, you can use completing the square and quadratic formula to determine the solutions of this given quadratic equation. So, by factoring, the possible factors of our given trinomial would be x plus 2 times quantity x plus 7 equals 0. Applying zero product property, we will have x plus 2 equals 0 and x plus 7 equals 0. First solution is equal to negative 2 and the second solution is equal to negative 7. So after we determine the solutions of our quadratic equation, the next thing that we will do is to complete the table of values for our x and y. This means we will have a table. Preferably, we will have 6 columns. First column is for our x and y. So we will have negative 2, negative 7, negative 1, 0, and of course left of negative 7 is negative 8. So when x is negative 7 and negative 2, it is because our y is 0. Then we will complete the table as we solve for y when x is negative 8. So here, if x is equal to negative 8, using our quadratic function, we will determine the value of our y. So we will have y equals x squared, we have negative 8 squared plus 9 times negative 8 plus 14. So we have y equals 64 minus 72 plus 14. So to simplify, y is equal to 64 minus 72. We have negative 8 plus 14. We have positive 6. So the value of our y is 6 when x is negative 8. So we will have to place 6 here. If our x is negative 1, let's determine the value of our y as we substitute negative 1 to our x. So we have y is equal to 1 minus 9 plus 14. To simplify, 1 minus 9, we have negative 8 plus 14. Again, we will have positive 6. So here, the value of our y is 6 when x is equal to negative 1. And if our x is equal to 0, substitute all x by 0 to determine our y. So we will have 0 squared plus 9 times 0 plus 14. So we have y is equal to 0 plus 0 plus 14, and that is equal to 14. So we'll have the value of our y, which is equal to 14 when x is 0. So after we complete the table of our x and y, the next thing that we will do is to graph these points. Again, let's try to create the parabola. So this is the graph of our quadratic inequality. So to create our Cartesian coordinate plane, let us also consider the different ordered pairs present in our table of x and y. So to illustrate this in our Cartesian coordinate plane, then let us plot the following points. Then, let us connect the following points. Remember again, the inequality symbol is very essential in connecting this point. In this example, our inequality is greater than equal to. So, if our inequality symbol is greater than or equal to, we will utilize the solid line. Then after we connect the following points using a solid line, the next thing that we will do is to undergo testing. Again, in testing, we will test point that is present inside our parabola and point outside the parabola. So we will test point inside and we will try to locate a point here. So the ordered pair of this point is negative 4, 0. So you have negative 4, 0. So allow me to use negative 4, 0, where x is negative 4 and y is 0. So using our quadratic inequality, wherein y is greater than or equal to x squared plus 9x plus 14, substitute our y, which is 0, and our x, which is negative 4. So we have 0 greater than or equal to 16 minus 36 plus 14. So 0 is greater than or equal to 16 minus 36. We have negative 20 plus 14. We have negative 6. So 0 is greater than or equal to negative 6. Of course, 0 is greater than a negative number. So we will consider this statement true. On the other hand, we will also test a point that is outside, and in this case, the point of origin is a point that is outside our parabola. So we will use this one as our testing point. So we will utilize 0, 0. So we will have y, which is 0, and our x, which is 0 as well. So we have 0 greater than or equal to 0 plus 0 plus 14. So we have 0 greater than or equal to 14. So here, 0 is greater than or equal to 14. And that concept is considered to be false. So we will label this one as a false statement. So here, we able to test point inside the parabola and it satisfies our inequality. This means points that is inside our parabola are all solutions of our quadratic inequality. And of course, if we still remember, we connected our ordered pairs with a solid line, and it also satisfies that all points that is along our parabola is considered also solutions of our quadratic inequality. So to give the graph of our quadratic inequality, we will shade all points that is present inside our parabola. This justifies that all points here are all solutions of our quadratic inequality, including the point that is along our parabola. And for our conclusion, we can state that the solutions of y greater than or equal to x squared plus 9x plus 14 are all points inside our parabola and points along our parabola. There you have it. Hope you learned something new today. God bless us all.